Alright, so I'm Gavin Sinclair. Today we're solving cubic equations. Overview of the talk. We're briefly on polynomials, sort of numerical examples, quick information on cubics. Then we'll get into the details. Bit of a summary because it will be very difficult to keep track. I promise you this will be difficult. And then we'll get into the history. And that means, so like I say, quick, all right, this is too slow. Quick, slow, quick, numerical examples there. When we look at the depressed cubics, that'll be algebraic. And then the history is whatever I remember, which should be pretty good. You'll be disappointed if I don't get to that, so I will need to go quickly through this stuff, and the article has all the details. I have to give credit to this book. It's a wonderful book. I've only read 2 chapters. The first chapter was the basis for this talk. Now I read that chapter about a year ago, and I'm worried what I might end up doing if I read more. So I was not expecting to encounter cubic equations when I picked up a book about complex numbers, but that was in chapter 1. Okay, so just to put cubic equations in context, we'll just have a look at polynomials. So this is the easiest slide, right? X plus A equals 0, so linear equations are easily solved. Quadratic equations have 2 solutions, and these have been known for a long time. Right? So the ancient, the sort of latter period Babylonians and Chinese both knew about completing the square around 200 to 300 BC. I think Euclid knew something about it. So quadratic equations have been known for a long time. Cubic equations, well, here's a cubic formula. That's for one of the solutions. There's the second one, and there's the third one. You notice anything funny? I. Now, to the best of my knowledge, there are lots of cubic equations that have only real solutions. But, there you go. There's one of the solutions of a quartic equation. There's all of the solutions written in a more schematic form. Right, so it's quite amazing. And then quintic, there is no formula. Now, how many people knew that? Okay, about half. So there is no way to write down a general solution for that equation. And I've known, oh yes.
So do you know why Gauss couldn't find a solution for the quintic equation?
Yes.
Because he wasn't able.
Oh. Abel was the first to prove that there is no solution, no general solution to the quintic. Now, I've known for many years that this had no solution, but I only learnt this week that it kind of does. The 5th root of x is the inverse of x to the 5, correct? If we just had some notation that was the inverse of x to the 5 plus x, then we could write the solution to that formula. Make sense?